Hello, and welcome to TDA Research's presentation. Today, I will be talking to you about our technology titled Reactive Boron Fuel for Energetic Applications. TDA Research develops and commercializes advanced materials for defense, aerospace, and other applications. TDA's commercial technologies include sulfa-trap sorbents, personal protective equipment, SSDX aircraft cleaners, carbons, and polymers. Our numerous patents support business spin-offs, licensing, and joint ventures. TDA, located near Denver, Colorado, has fully equipped laboratories and facilities. TDA has developed novel explosives, propellants, and pyrotechnics for the Department of Defense under SBIR and STTR contracts. These include igniters, conducting additives, propellant ingredients, and 3D printable solid propellant binder materials. TDA's successfully transitioned technologies include the carbon monoxide oxidation catalyst in the oxygen generators that are used in U.S. Navy's FA-18 fighter aircraft fleet and SSDX aircraft cleaners that are used for chemical and biological defense. The Navy seeks to use boron in energetic formulations, especially in solid and liquid fuels. Boron is highly energetic but is normally difficult to use in solid and liquid fuels. The Navy wants to use boron as a fuel ingredient to improve the performance, range, and/or speed of missiles and rockets. The targeted technology areas include air platforms, materials, and weapons. The boron materials need to be non-hazardous while working with both liquid and solid fuels. They also need to meet energetic materials testing standard operating procedure requirements at Naval Air Warfare Center Weapons Division China Lake, while giving improved performance over conventional fuels that lack boron. The Navy wants a boron-based performance-enhancing ingredient for fuels so that the range and speed of missiles can be increased. The boron ingredients will be additions or subcomponents to a Navy missile propulsion system. The Navy would like to see increases of up to 10% over the baselines in range and/or speed. There is currently no other drop-in additive for using in Navy fuels, and our drop-in additives can be tailored to mission needs. The enhanced performance that results when using our additives will increase the range and lethality of weapons. TDA has developed new boron materials to attain the Navy's goals. These new materials can be directly mixed into the current ingredients of both liquid fuels and in solid propellant formulations. TDA's research and development program includes chemical synthesis and thermochemical testing. Our technology enables safe mixing of boron into currently used rocket fuels for the first time. We estimate that the technology readiness level TRL is currently 2 or 3. We expect that TRL will be 4 or 5 after the boron additives are demonstrated in small-scale rocket motor testing. We are currently working to develop boron fuel additives further. There is more testing that needs to be done, both with the Navy and with a future prime contractor. The TRL will rise after demonstrating our additives in small-scale rocket motor testing. Currently, the project is in the Phase 2 option period, which is scheduled to continue into January 2026. We have performance and energetics testing activities planned at Naval Air Warfare Center Weapons Division China Lake for the next several months. We will need additional funding to continue developing and testing the additives, along with Navy validation. We anticipate producing boron materials at larger scales in-house at TDA. Beyond this, a prime contractor will likely continue production of the additives for propellant manufacturing. TDA's boron-based materials can be directly mixed into current ingredients of both liquid and solid fuels. We recognize that using a drop-in additive with current fuel formulations is simpler to implement than a totally new fuel. This should offer a faster pathway to qualifying their use. There is currently no equivalent competing boron technology. Using our boron additives will improve the performance of Navy missiles. The new boron technology will make the missiles faster and/or have longer ranges. The drop-in nature of the additives will allow the Navy to keep the current form factors of the weapons when using them. Thus, performance improvements will come without disrupting the size and weight of current weapons. The cost of the boron additives is expected to be reasonable. In order to transition our boron additives beyond Phase 2, several things need to be accomplished first. These steps include demonstrating TDA's boron additives in small-scale rocket motors, further testing and qualification in Navy systems, and scaling up additive production and manufacturing. For all these steps, additional funding beyond the first Phase 2 option period will be needed. The main Navy transition advocate is NAVAIR PEOU and W, primarily PMA 201, along with PMA 259. The boron additives will be additives or subcomponents of Navy missile propulsion systems. We predict that there is a broad market potential for boron fuel additives. The drop in performance boost offered by the additives with current solid and liquid fuels will broaden their market appeal. Department of Defense applications for the additives will include afterburners, rotating detonation engines, and solid and liquid-fueled missiles. There are also potential applications in commercial space launch for the additives. No other boron-based fuel additive is known that has the attributes and utility of our technology. Thus, we expect that our technology will lead the market for boron-based performance-enhancing additives, while opening new markets in solid and liquid propulsion for the Navy and the Department of Defense. To advance our boron additive technology, we need additional support from several areas, including support from a major industry partner and the Navy. Further funding will be needed to conduct production scale-up, testing, and qualifications. Eventually, the technology needs to be demonstrated with a system-level test bed, or in operation in a real system. Other transition opportunities for our technology include Air Force and Army missiles and other rocket-propelled munitions. TDA expects to support the prime or system integrator with expertise on producing the additives and using the technology. Interested? Come talk with experts at TDA Research. The TDA point of contact for follow-up on boron-based fuels is Dr. Girish Srinivas. He is the CEO of TDA. Please contact him at the information listed on this slide. TDA is located in Golden, Colorado, which is in the Metro Denver area. Our address is listed on this slide. The TDA website is found at tda.com. Boron is the next generation fuel enhancer. TDA's innovative propulsion additives are practical, safe, and effective. Thank you for your time.